In this first oxidation number video, I'm going to take a look at how you calculate oxidation number. So we'll start with these three simple dot and cross diagrams for hydrogen, chlorine and hydrogen chloride. And I'm just going to tell you that in the first one, hydrogen has an oxidation number of 0. In the second one, chlorine has an oxidation number of 0. Whereas in the third one, hydrogen has an oxidation number of +1, chlorine has an oxidation number of -1. So to explain all of that, we need to bring in the definition, which looks like that. So definition of oxidation number is the number of electrons that an atom uses to bond with the atoms of another element. So if you think about the H2 molecule, well, hydrogen isn't bonding to anything different. They're both hydrogen, and so the oxidation number by definition has to be 0. Same goes for chlorine. Whereas in hydrogen chloride, you can see the dot and cross at the bottom there. Hydrogen's using one electron to bond to the chlorine. Chlorine is using one of its electrons to bond to the hydrogen. Now, the business about the signs, why the hydrogen is +1 and the chlorine is -1, that comes from a concept called electronegativity. So I would strongly recommend, if you haven't already done so, get your head around electronegativity. I've made an introduction to electronegativity. The link to that should be on the screen now. So I would really recommend that you get your head around that before you go any further. Okay, so to calculate the oxidation number, we need to follow a set of rules. So I'm going to go through the rules now, give you some examples, and then give you some examples to try for yourself. So rule number 1, all pure elements have an oxidation number of 0. We've just seen that because they're not bonding to a different type of atom. So all elements or pure elements have an oxidation number of 0. So there's 3 examples, just 3 different elements. The next rule is group 1, 2 and 3 atoms, when they're in compound, so in other words bonded to something different, they are always +1 for group 1, +2 for group 2, +3 for group 3. So there's 3 examples there. So in potassium iodide, the potassium atom has an oxidation number of +1. Magnesium is always +2 in its compounds. Aluminium is always +3 in its compounds. The next rule is fluorine is always -1. And that's because fluorine is the most electronegative element, and that's where the knowledge of electronegativity really comes in handy here. So fluorine is always -1. So there's 3 examples there. So fluorine in all of these is always -1. Okay, the next 3 are a little bit trickier because we move away from always in the rule and it goes to usually. So hydrogen is usually +1. So some examples of that: hydrogen in methane, hydrogen in water, hydrogen in ammonia, +1. So when is it not +1? It's when the hydrogen is bonded to a metal. So that's called a metal hydride, and hydrogen has a -1 oxidation number then. And that's basically because metals always have to have a positive oxidation number. So when bonded to a metal, hydrogen has a -1 oxidation number. Next rule, oxygen is usually -2. So here's some examples of when oxygen is -2. So when is it not -2? Well, the first example is when it's bonded to fluorine, and that's because fluorine is more electronegative than oxygen. So it has to be +2. And in something called a peroxide, oxygen has a -1 oxidation number. And the final rule is about chlorine, so that's usually -1. There's some examples. But when it's bonded to fluorine or oxygen, they're both more electronegative than the chlorine, it has to have a positive oxidation number. Okay, so before we look at some specific examples, I'm just going to run through 3 simple steps that you have to follow to calculate the oxidation number of an atom when it's in a compound. So step 1, assign the known oxidation numbers from the rules. Step 2, the overall charge of the species is equal to the sum of all the oxidation numbers. And the final step, calculate the oxidation number for the unknown atom. Right, so there's some examples for you to try. So if you feel like you want to have a go at this, just pause the video now and then play on when you're ready for the answers. Otherwise, just keep playing and I'm going to go through the answers very shortly. Okay, so we'll make a start on the answers. So the first one, carbon dioxide, we've got oxygens in the rules, so -2 twice because there's 2 O's in CO2. So the overall charge is 0. So to get the charge to 0, this needs to be putting in +4. So the answer to number 1 was +4. The next one, got to find out the carbon oxidation number in methane. Again, hydrogen's in the rules. So it's not bonded to a metal, so it's definitely +1. So there's 4 of those. Remember, oxidation number is about each atom, so +1 times 4. To keep the charge at 0, this needs to be -4. Okay, so moving on to number 3, we've got to work out the oxidation number of the oxygen here. So it's normally -2, obviously isn't going to be in this one. So we've got a group 1 metal in there, so they're always +1, so it's 2 of those. So we've got no overall charge, so the 2 oxygens must be putting -2 in. So that means each oxygen is -1. So this is an example of a peroxide. This is sodium peroxide. And so it's following that rule that when you've got oxygen in a peroxide, it's -1. Okay, so the last one on this side, we've got to work out the oxidation number of hydrogen in AlH3. Well, aluminium's in group 3, so it's got to be +3. So the combined hydrogen, the 3 hydrogens have got to put in -3 to give it no charge, and so each one has to be -1. So the answer is -1 for the hydrogen. And this is an example of a metal hydride. This is aluminium hydride. Okay, so moving on to this side now, we've got to work out the oxidation number of the chlorine. So we've got +1 for that hydrogen. There's no metal in there, so it's definitely +1. Oxygen is usually -2 unless fluorine's in there. Well, there's no fluorine in there. This is not a peroxide, and so -2 times 3. So the chlorine is going to have to be +5. So when you combine the +1 and the +5 and add it to the 3 -2, you get no overall charge. Right, so to finish, we've got 2 ions. So we've got to work out the sulfur in this ion here. So we've got 4 oxygens, -2 times 4. So that's -8. But when we add this oxidation number, we need to get the overall charge, which is 2-. So this is going to have to be +6. Okay, so moving on to the last one, we've got this ion of chromium and oxygen. So we've got 7 O's, so -2 times 7. -14 combined for those, but we need to be left with a 2- charge. So the 2 chromiums must be putting in +12, so that means they must be +6 each. So I hope that was helpful and you feel a lot more confident about working out oxidation numbers.